Hey guys, time for video number 3. This video is about segment and angle addition. So go ahead and take out your geobooks and let's get started. Okay, so go ahead and turn in your vocab books to the next available vocabulary word section. Your first word for today is segment addition postulate. And postulate over here, it's over here on the bottom. Postulate means that a statement which is taken to be true without proof. So there's nothing that we need to prove. There's nothing, extra that we need to do. It's just a fact. A postulate is just a fact that's given to us. So what this postulate says is that if a point B lies on a line segment AC, then AB plus BC is equal to AC. And it sounds a little wordy, but you don't really have to worry about it because it's a very, very, very simple concept. So it pretty much just says that you start off with a line segment. So in this case, we have a line segment from A to C, and you put a point anywhere in between this line segment. So it could be here, it could be here, it could be here, anywhere here. In this case, we put point B over here. So when you put point B, you pretty much just created two more segments of that one segment AC. But you really aren't adding any length to your segment AC. You're just breaking it up into two different parts. So for example, we have this part here. We can call that segment AB. And then we have another part here. We can call that segment BC. And the postulate says that if you take those two segments, so segment AB and segment AB and segment BC, and you add them together, you get the length of the entire segment that you started with, which was AC. So in other words, let me give you another quick example. So think back when you guys were starting, when you guys were doing the, the Ferris wheel project. So remember that we started the Ferris wheel with some sucker sticks, and we had to cut them at certain measurements. So remember that each sucker stick was 6 inches long, and for one of the measurements, we had to cut the sucker stick at 2 inches, so at every 2 inches. So we ended up with 3 sticks that were 2 inches long. So let me put that right here. So each stick that we cut was 2 inches long. 2 and 2 and 2 and 2. Now, if we use the segment addition postulate that we're talking about right now, it pretty much says that you take all those segments, so this segment here, and this segment here, and this segment here, and you add them together, then you get the length of your entire segment, which is 6. And if we look at it, we have 2 here, so 2 plus 2 is 4, plus 2 is 6. So indeed, we do have our initial length, which was 6 inches. So go ahead and pause this video and write everything that you need in your vocab book so we can go to the next slide. Okay, so the next vocab word is angle addition postulate. So there we have the same word postulate again. And this postulate, it says that if a point S lies in the interior of angle PQR, so here's angle PQR, then angle PQS plus angle SQR is equal to angle PQR. So it's very, very similar to the segment addition postulate that we talked about in the previous slide, but now we're just talking about angles. So if we have, we have this point here that is inside the angle PQR, and that point right there, it could be anywhere here inside that angle. I can put a point here, I can put a point here, anywhere. And then I have to connect that point and the vertex. So from the vertex, I create a ray, and now I have created two angles from that one angle that we started with, which was PQR. So now that I have two angles, so here's angle PQS. So this angle here is angle PQS. And this other angle over here is angle SQR. And remember to name your angles. Remember that you have to start at one point, but it can't be the vertex point. So you have to start at one of the end points, and you go towards the vertex point, and then to the other point on the angle. So in this case, this is P angle PQR. It's like if you were following along that line. And this angle over here is angle SQR, this blue angle over here. And then this angle, this red angle is the PQS. So following the same thing that we were doing for the segment addition postulate, we take the measurement of each of those angles. So angle PQS, there we go. So we take the measurement of each of the angles, so the measurement of angle PQS and the measurement of angle SQR, and we add them together. And when we add them together, we should end up, when you add them together, we should end up with the measurement of the entire angle PQR. So we're taking each of those angles, PQS and SQR, and we add them together and we get the measurement of the entire angle PQR. So go ahead and pause the video and make sure that you write this in your vocab book. Okay, so our last vocabulary word for today is the word congruent, and this is the symbol that we use for congruent. So it pretty much looks like an equal sign, but it has this little squiggly line right here on top. So just know whenever you see this symbol, we're talking about congruent. And the definition for congruent is having the same size and shape, or in other words, you can just really think of it as having two things that are equal. So two equal triangles or two equal angles, two equal segments, any two things or more that are equal to each other. And the way that we read the statement, so I have an example right here. We'll go to this and then we'll go to the examples over here. So whenever you see something like this, you read it the following way. So this right here says angle A, so that is this part here, is congruent to, so whenever you see this congruent symbol here, you read it as is congruent to, and then angle B. So this statement says angle A is congruent to angle B. Now let's look at the examples that we have over here on the right side. We have this angle here that we're going to call G, and this angle here that we're going to call S. And the reason that we know that they're congruent is because both of them have 42 degrees, both of them are 42 degree angles. This is 42 and this is 42. And so when we write it, we put angle G is congruent to angle S. Now, it doesn't show it on the picture, but most of the time when two angles are congruent, you're going to see that they put a little arc right there on the angle. And if it has that arc, that means that those two angles are congruent. Okay, so if we look at the second example over here, now we're talking about congruent segments. So this right here says segment EF is congruent to segment HG. So these two segments are exactly the same. Even though they're not going in the same direction, this one's going this way and this one's going a little bit more down, they're still congruent because we don't really worry about direction. We worry about the length and the size. So, so you know how over here we had arcs to show that these two angles are congruent? Well, to show that two segments are congruent, we don't use an arc, but we use a little dash. right here. So we have a dash right there, and we have a dash right here, and this right here tells me that these two segments, EF and HG, are congruent to each other. So go ahead and pause the video and write this down in your vocab book. Okay, so we are done with the vocab section of your GeoBook. Now go ahead and turn to the notes section of your vocab book and write the title, segment and angle bisector. Most of the time we are only going to work out 3 problems on the videos, but in this particular video we're going to work out all 4 problems. Okay, so the first problem says that segment DF is bisected by line L at point E. If the length of DE is 13, find the length of EF and DF. Now this word right here we haven't talked about, but I put right here what it means. Bisect means that you're dividing into 2 equal parts. So if you go back and look at the problem, it says that segment DF is bisected by line L. So this line over here is bisecting or dividing your segment DF into 2 equal parts. And over here on the problem, it tells me that DE is 13. So from here to here is 13 units. Now, again, let's look at what bisected means. Bisected means that I'm dividing my segment DF into 2 equal parts. So if this right here from D to E is 13, then that means that from E to F is also 13 units. So 13. So from here to here is 13, and from here to here is also 13. So we already found what the length of EF is. So EF is equal to 13, and we know that because the problem told me that line L, so this line here, bisected, which means that it divided my segment DF in half. So it cut it right here in half. So this is 13, this is 13. So now that we have both of these measurements from DE and then from EF, now we can find the measurement of DF. And if we use the segment addition postulate that we were talking about earlier, then we know that DF is equal to DE plus EF. We're going to take DE from here, and we're going to add EF, and the sum of those 2 lengths should give me the entire segment. So if we look at DE, DE is 13. We know that EF is 13 because it was bisected by line L. And so if we add those 2 together, we get that 13 plus 13 is 26. So the length of DF is equal to 26, and we already know that the length of EF is equal to 13. Okay, so problem number 2 says ray EF bisects angle DEG. So here's our ray EF, and here's our angle DEG. And remember, bisects means that you are cutting something in half. So in the previous problem, we were cutting a segment in half. In this problem, we're going to cut an angle in half. Okay, and then another part of the problem says if measurement of angle DEG, so from here to here to here, this angle here is 88. So let me go ahead and mark that right there. All of this right here is 88 degrees. We need to find the measurement of angle FEG. So I'm going to take my color here, and I just want to find the measurement of angle FEG. So from here FEG, which means I'm looking for this angle right here and only this angle right here. Okay, so to do that, we need to think about bisects right here. We need to think about that word. If it is bisecting, that means that we're cutting the angle in half. So if the whole angle here from angle DEG is 88 degrees, then if we cut it in half right here with this ray EF, then that means that half of 88 goes here and half of 88 goes here. So half of 88, if you put that in the calculator, if you know that, you divide that in your head, you know that 88 divided by 2 is 44. So this right here, angle FEG is 44 degrees. And the way that we write that, measurement of angle FEG is equal to 44 degrees. Okay, so this next problem is about complementary angles. And you guys, we've talked about this complementary angles before, but we didn't have an example for it. And the reason why we put it in this video is because it has to do with the angle addition postulate that we were talking about earlier. So if you remember from the previous video, complementary angles are two angles that they add up to 90 degrees. And that's complementary angles, because we do have supplementary angles, which is going to be the next example. But complementary angles, they add up to 90 degrees. So in this case here, we have two angles here. So angle ABD and angle DBC. And we know that they're complementary, first because they tell us here on the directions on top, but also because if you look over here, it has the little right angle box. Remember, whenever you see this box here, that tells you that that those angles right there are 90 degrees. So what we're going to do for this problem is we first have to set up an equation, because we need to find the value of x, and we can see that x is right over here. X is right over here. But there really isn't any equation that we have that we can solve for x. So we have to set up our equation. And in geometry, that's what we have to get used to. They give us information and we set up an equation. So for this example, we know that we have two complementary angles. And that's angle ABD and angle DBC. Okay, so to set up our equation, we're going to take this angle here, ABD. So we're going to write measurement of angle ABD plus measurement of angle DBC. And we're going to equal that to something. Now here's the important thing. We have to equal it to the right degree. And we have to look back at our problem over here. And our problem tells me that these two are complementary angles. And remember, we said complementary. Whenever you think complementary, you think 90, because complementary angles and 90 degrees, they kind of go hand in hand. So we have to set up our equation here to 90 degrees, because we know that the sum of our two angles, ABD and DBC, is equal to 90 degrees. Okay, so let's go ahead and fill in our equation. So from angle ABD, I'm going to get our 62 plus measurement of angle DBC. It tells me that is 2x plus 4, and we keep our 90. And from here on now, we just do our algebra. So again, the geometry part was setting up the equation, and from there is just solving, and we just do algebra. So we can combine like terms. So here is 62 and here is 4. 62 plus 4 is 66. So let me go ahead and write this. we're gonna end up with 2x plus 66, and that is equal to 90. And to get rid of the 66 over here, we can subtract 66 from both sides. These right here will cancel out, and we end up with 2x equals, what is it? 24. So 2x equals 24, and do the same thing to get rid of the 2 over here by the x. We divide by 2. The 2's cancel out, and we're left with x equals 12. So that right there is our final answer. So go ahead and write this in your geobook. Okay, so this is our final example. And sorry about this, it says example 3, but this should actually be example 4. So this last example is similar to the previous one with complementary angles, but now we're working with supplementary angles. And we have to do the same thing. We have to find the value of x. So we have two angles here. We have angle ABC and we have angle CBD. So to set up the equation, we take angle ABC. So let me write this down over here. Measurement of angle ABC plus measurement of angle CBD. And we're going to equal it to 180 degrees. So let's go ahead and fill out this equation. From my angle ABC, I'm going to put 2x minus 10. And then from this angle over here, CBD, I'm going to put x minus 11. And we still equal it to 180 degrees. So again, now it's just doing the algebra. We're going to combine like terms. So we have a negative 10 and we have a negative 11. And when we combine those, and we also have a 2x and an x right here. So I'm going to combine them in the same step so I can save some space on the bottom. So, but the 2x and the x, that becomes 3x. And then the negative 10 plus the negative 11, that becomes negative 21. And that is equal to 180 degrees. And we're going to move the 21 over to the right side. So plus 21, and I'm running out of space here. Maybe I can move this. Oh yeah, I can move this up a little bit. It's just a different color, but that's okay. So now I have plus 21 on both sides. These right here cancel out. And I end up with 3x equals 201. And then to finally get x by itself, we divide both sides by 3. And the 3's over here cancel out, and we're left with x equals 67. Okay, so go ahead and write this in your geobook. And just make sure you let the video play all the way through so that you can see your score at the end. If you don't let the video play all the way, then you won't be able to see your score. Okay, just one last thing. Don't forget to go back and fill out your table of contents and make sure that you're all up to date on that, okay? Okay, thank you guys so much for listening, and I hope you guys have a great day.